Okay, chapter 17, day number 1, complex numbers and complex properties. We are going to do a lot of, how shall I say, rationalizing the denominator. Okay, some of you avoided that, but now you're not going to be able to because we need to in order to put complex numbers into a certain form. What is the form of a complex number? Well, it comes in this form. You may remember this. Remember that? From higher algebra. You guys did a lot of foiling with complex numbers. Okay, so a complex number z has a real portion and it has an imaginary portion. Okay, so that could come in this form. Okay, here's an imaginary number. Whoops, I need a number there. How about 5 plus I? Ooh, that's an imaginary number. How about -7 minus 3i? Yeah, that's an imaginary number. How about this? Is this imaginary? Is that imaginary? No. Well, technically it's complex. It's just not imaginary. All right, it's complex because how many? There is no imaginary portion. You could write it as a complex number. Okay, and where are these located? Okay, so let's plot these on the imaginary axis. The real portion is on what we used to call the x-axis. And the imaginary portion is on what we're used to calling the y-axis. So the point 5 plus I, this one right here, is to the right 5 and up how many? I, 1. That right there is the point 5 plus I. What quadrant would 7 minus 3i be in? Fourth quadrant. Fourth quadrant of the complex number plane. So I'd go over 7 and I'd go down 3. And so, poorly placed. That would be z, let's call it z2 right here. Okay? That's our second complex number, which was, that's a -7. What the heck? I'm going to change that. Just because I'm going to change it to a positive because I already plotted it. Okay. All right. Good adjustment. Way to go. Veteran move. All right. How about 8 plus 0i? Just on that real axis. Right, it'd be right here. All right. This would be z3. Z3, which is 8 plus 0i. So there's no imaginary portion. Okay, so that's the complex plane. We're going to do some stuff with that as we go through this chapter. Just out of curiosity, what if I told you that I had this one, I don't know, 1 minus I. Do you think that would be a 30-60-90 or a 45-45-90 triangle form? Yeah, oh yeah, now we're getting into it, right? So I'm going to go right 1 and down 1. So this point right here is the point 1 minus I. And so there is a triangle formed here where this side is 1 and this side is -1. Well, we'd call it -1i. What would the hypotenuse be? Yeah, root 2. So I have pi over 4 right here, right? So, oh my gosh, last chapter is not disappearing. It's just becoming more complex. Ba-da-ba-ba. Okay, so this right here is rectangular form for a complex number. I move right, I move down. I move right, I move down. We'll get to polar form later. Okay, this is actually, I'll show you, but this is rectangular form. You don't need to know this today, but here is polar form for the same position. How much did I extend out? No. Square root 2. Square root 2, cis, this is special language, -pi over 4. Cis, you'll learn later, but that's polar form for that complex number. Okay. Today. Okay, so today, this is a lab that we may or may not do. I'm going to skip this for now. Where do imaginary numbers come from? They come from parabolas or polynomials that never cross the x-axis. All right, so if I can't factor this polynomial, then I use the quadratic formula. Quadratic formula tells me x equals negative b plus or minus square root b squared minus 4ac all over 2a. I don't sing, only if it has to do with a triangle. You guys are very demanding right now. That's just mean. What is 9 minus 28? Yeah, how about negative 19? Oh, now I see. My two solutions in this case are going to be imaginary because this thing, right, this thing is not a real answer. If it comes out to be a positive number, then we know we have potentially one or two, well, potentially two, but definitely one solution. So when this thing, which is b squared minus 4ac, is less than 0, we know we have imaginary solutions. All right, so let's simplify this and put this into a plus bi form. So here's x. It's equal to negative 3 halves. I'm going to split it up immediately. Plus or minus. How would I rewrite this if I just had square root of 19? Yeah, I bring I out in front. I is equal to the square root of negative 1. All right, that's the imaginary unit. Don't ask me who came up with that because someone got bored with real numbers and said, let's come up with something else. All right, so we have two values. We have x equals negative 3 halves plus I root 19 over 2, and we have x equals negative 3 halves minus I root 19 over 2. What happens, you guys, is that these imaginary roots always come in pairs. Don't they look exactly the same except for one thing? Yeah, one of them is plus and one of them is minus. So they always come in conjugates. They always come in conjugates. That's a conjugate. Remember, old people love conjugates? What's the conjugate of x minus 3? X plus 3. What's the conjugate of 4 minus 3i? 4 plus 3i. Why do old people, yeah, they love this because all they have to do is first last, right? And that reminds them of home, Florida. Outside and inside terms cancel when you have conjugates. Would you please, in the next couple of minutes, FOIL that? 4 plus 3i, 4 minus 3i. Just take 2 minutes and see if you can put it into a plus bi form. Please, go. Okay. Hey, I heard it. So if I do first, I get 16, correct? If I do last, I get negative 9i squared. If I equals the square root of negative 1, I squared equals what? Negative 1. So this is 16 minus 9 times negative 1. I get 25. All right. So what we can do with complex numbers is, well, first of all, let's talk about I, right? We already know that I is the square root of negative 1. If I square that, I get negative 1. I cubed is like I times I squared. So if I take I times I squared, I get negative square root of negative 1, which is negative I. Right? And the best way I think of I to the fourth is I squared times I squared, which is negative 1 times negative 1. So it comes back to 1. So here are your first 4, and you only need 4. I is the square root of negative 1. I squared is -1. I cubed is -I. And I to the 4th. What happens here? It alternates between what? Imaginary, real, imaginary, real, imaginary, real, forever. Forever. Now, no, sit. Math. I to the 12th is I to the 4th to what power?
3.
To the 3rd. What is I to the 4th? 1. 1 to the 3rd is? 1. If the number here is divisible by 4, it's always 1.
Okay, but isn't it divisible by 3 also?
Yeah, but how many times? Always go with the easiest version. Go with the real possibilities, right? So how many times would 4 go into 25? 6, right? That's 24 with one I left over. Would you agree that I to the 24th times I to the 1st is I to the 25th? Yeah. So if I go with that logic, then I to the 4th is 1. I is itself, so I get I. Okay, how about I to the 129th? Okay, all right. Deal with it for a second, all right? 4 goes into 129 32 times. So I to the 4th. I to the 4th goes into 32 times. Guys, you need to be quiet and listen. I'm not afraid to put that on my channel. I think more people would watch them. Okay? Do you agree? Yeah. 4 times 32 is 128. Don't question it. I just did it 8 minutes ago in my head. Okay? All right. Times I. We know I to the 4th. It's our friend. It's 1. 1 to any power is going to be 1. And 1 times I is I. Okay, so you're saying, well, you did that intentionally, so you had I to the 4th always. Okay, somebody give me a number. Don't give me a negative number. 17? 37. Okay. Well, that's going to be nice, too. It's going to be I. How about 39? 39. Okay. I to the 39th. How many times does 4 go into 39? Well, 4 goes into 36, right? 4 goes into 36 with how many left over? 3 left over. So 4 goes into 36 9 times with I cubed left over. We know I cubed is what? I cubed is -I. So this is -I times, well, we know that's going to be 1 to the 9th. So the answer is -I. Okay, give me another number. 43. Well, that's going to be the same thing. 57. I to the 57th. Okay, so I already know this is going to be I, but that's okay. Because I to the 56th times I to the 1st. Well, how many times does 4 go into 56? How about 14? So I to the 4th to the 14th power times I to the 1st. Well, we know that's going to come out to be 1, because that's going to be 1 to the 14th times I. So that's just going to be I. Are you following my thinking here? Okay. I try to find out how many times 4 can go into something. You could do 2, right? But then you'd be working with -1 to the certain power. And that'll alternate back and forth depending on if it's an even or odd power. So I like 1 because it never changes. -1 changes constantly. Okay. Let's keep going. I don't like this slide. I don't even know what we're supposed to do here. All right, here it is. Adding, subtracting, multiplying, dividing. Let's do some quick addition. What is 1 minus 3? Okay, -2. What is -2 minus 4? Okay, done. There's A plus BI form. You have an imaginary or a complex number that has both a real and imaginary portion. Adding, subtracting, if you missed that, I will probably do mental push-ups at my desk until I burn out and then do a few more, because don't start counting until it starts hurting. Okay? All right. How about multiplication? We just did one on the last page, but they were conjugates, so we only had to do the Florida version, old people. So now we actually have to FOIL. All right, so I'm going to FOIL this. I get 3. I multiply those. That's first. How about outside? How about plus 4i? Inside, minus 6i. Last, I get negative 8i squared. What is the I squared going to do? It's going to be a negative 1. So this is really negative 8 times a negative 1, which will be a positive 8. So I'm going to combine like terms. I got a 3 and an 8. That makes 11. How many i's do I have? Negative 2i. Boom. There's your complex number. Okay. So on the first one, I get this complex number. Nice form. It looks very good. No fractions involved. Second one, there we go. Third one, yuck. How could I make the denominator into one single real term? No. Conjugate. Conjugate will make any complex number turn into a real number. Like on the previous page, or 2 pages ago, or whatever, where we did. Oh, proofs unit 2, yeah. Yeah, heck yeah. What I'm going to do is I'm going to multiply top and bottom. Did we? Yeah, we did. Oh my gosh. Wow, how well did that work out? I didn't even plan that, you guys. I didn't. We already, on 2 slides ago, we did 3 minus 4i times 3 plus 4i. What was it? 25, right? 25. So the denominator, that's creepy, actually. I didn't plan that. Maybe, I don't know. I honestly did not plan it. I seriously didn't. Yeah, it was the gains. From my gains inside my head. Yeah. Ah. Okay, now the top we have to FOIL. Oh, it's same as the second one. How lucky. No, I honestly, it wasn't intentional on my part. I have to split this, though. So I got to write it like this. Here's my real portion. Here's my imaginary portion. Really, children, really. That is my complex number in A plus BI form. Okay, the last 3 here, 4 and 5 are going to go swiftly, very swiftly. Would you agree that the square root of negative 3 is the square root of negative 1 times the square root of 3? Okay, so that's I root 3. Do you agree then that this is negative 1 root 12? Yeah, that's I root 12. So if I multiply I times I get I squared. If I multiply root 3 times root 12, this is going to blow some minds, it's 6. What? Wait a minute. Because it's the square root of what? 36. Yeah, so I get the square root of 36. I squared is what? So I get negative 6. Ciao. Okay, what is negative 3 times negative 12? Okay, and what's the square root of 36? Boom, done. Gains. All right, so here's where the rubber kind of meets the road a little bit. This has to be FOILed. Not bad at all. Honestly, not bad at all. Okay, let's take it piece by piece. First, x times x squared. Thanks. That's easy. Okay, outside. Well, I'm going to take this imaginary portion. That's an I, not an x. 1 minus 2i. And I'm going to multiply it by x. How about inside? Kind of the same thing. 1 plus 2i times x. And then last. Okay, now if you look at these, if I multiply a negative times a negative, it'll kind of go away, and then they're conjugates. I got 1 plus 2i and 1 minus 2i. So Florida tells me 1 times 1 is 1, and 2 times negative 2 is negative 4i squared. So I'll get plus 1 and minus 4i squared. I squared is negative 1. So 1 minus a negative 4 is a positive 5. That would equate to a positive 5. All right, let's clean up the rest of this garbage. All right, I got an x squared. If I distribute an x to each of these terms, I'd get negative x plus 2ix. Where'd you get the plus? Well, negative of a negative, right? And then what do I get in the other one? Negative x minus 2ix. So the 2ix and the negative 2ix, they go. What happens with these two? Yeah, so I get x squared minus 2x plus 5 if I FOIL that out. Oh, what the heck? If I would have done quadratic formula, what would I have ended up with? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's see what it comes out to be. X equals 2 plus or minus the square root of what? Negative 16 all over 2. Keep going. X equals 2 over 2 plus or minus, how about 4i over 2? With me? What is 2 over 2? 1 plus or minus 2i. Where do you see a 1 plus or minus 2i? Yow. Yow. 1 plus 2i, 1 minus 2i. Those are your two zeros. Oh. Yay. All right, couple things I got to tell you about the next slide is this. If I want to take z plus w, that's cash money in the bank. The chicken is free. All right, I'm going to add them together. Does w have a real portion? No. So it'll be 2 plus how many i's? 7i. Good. Don't write it like that. 7i. Okay. How about z times w? Wouldn't I just distribute? Okay, so I'd get 8i, and then I'd get 12i squared. I squared is negative 1. So I would rewrite it in this form. Done. With me? Keep your eyes up here. Okay, what about 1 over z? Well, 1 over 2 plus 3i. What am I going to multiply top and bottom times? 2 minus 3i. Conjugate Florida. Love it. Okay, what's 2 times 2? 4. What's 3 times negative 3? Negative 9, but the I squared makes it positive 9. So I'm going to get this. I think 2 minus 3i over 13. That was convenient because, oh, the 1. Thanks. Okay, then there's a notation issue that you need to be aware of. What in the world is that? Huh? Line just means conjugate. Line over the top means conjugate. So if z equaled 2 plus 3i, then z with a bar over it is 2 minus 3i. That's it. That's just short notation for that is the conjugate. So if I put a line over the top of a letter, a complex number, right, that means you're going to turn it into its conjugate. So this right here, what's 13? This one? Oh, yeah, that's exactly what it would be. Z is 2 plus 3i. Z bar is 2 minus 3i. And we already calculated it up here. Is going to be 4 minus 9i squared. That's 4 minus 9 times negative 1, which is 4 plus 9, which is 13. $100 sub GNC $12 gift card.